Hello everyone, and welcome back to STEAM Aspirations. Today we'll be solving problem number 25 of the 2015 AMC 8. We have that 1-inch squares are cut from the corners of this 5-inch square. What is the area in square inches of the largest square that can be fitted into the remaining space? So let's first draw a diagram. Intuitively, we know that the square will be diagonal, not straight, and it will be touching each of the four corners of the little gray squares. So let's just sort of try to draw a diagram of that. So we have this triangle. This probably won't be very accurate, but it should suffice. Alright, yeah, so the square looks something like this, except a little bit less bendy and more straight. So we notice that there's four triangles here. Let's just use this sort of smaller triangle right here to illustrate because it is the neatest. So let me just zoom into that. Alright. So we know that this square has side lengths of 1. And we know that all four of these right triangles, because of side angle side, are going to be congruent. So this triangle, this triangle, this triangle, and this triangle, even though they may not look like it, are all congruent. Yeah. So let's just look at this top left corner triangle. So we know that the side length of the gray square is 1. Let's just note this longer length as x. So what do we know about the smaller length? Well, if we denote the smaller length, let me just redraw that line. The smaller length as y, we know that since these triangles are congruent, this is also y right here, which means that x plus y is going to be equal to 5 minus 1 minus 1, because this is also 1, which is going to be equal to 3, which means y is just going to be 3 minus x. So we can replace this y here with 3 minus x. And something else we know is that these two smaller right triangles are both similar to the larger right triangle, which means that they're also similar to each other. This means that we know that the ratio of this length and this length is going to be the same as the ratio of this length and this length, which means that we have x over 1 is going to be equal to 1 over 3 minus x, or in other words, 3x minus x squared is going to be equal to 1, or x squared minus 3x plus 1 is going to be equal to 0. So now what we can do is we can just find the roots of this to find what x is using the quadratic formula. So we have x is equal to negative of negative 3 plus or minus square root of negative 3 squared minus 4 times 1 all over 2 times 1. This is going to be equal to 3 plus or minus square root of negative 3 squared is 9 minus 4 times 1, which is 4, is going to be 5 over 2. And now we just look at, so we know that x is going to be equal to 3 plus or minus root 5 over 2, but we also notice that 3 plus root 5 over 2 plus 3 minus root 5 over 2 is just going to be equal to 3, which means that one of these roots is going to be x, the other is going to be 3 minus x. So in this diagram, we have that x is the larger one, so let's just let x equal 3 plus root 5 over 2. So we have that this is 3 plus root 5 over 2, which means that 3 minus x is going to be 3 minus root 5 over 2. Now we can use the Pythagorean theorem to find the square of the side length of this square, which is the area of the square. So we use the Pythagorean theorem on this triangle right here. And the Pythagorean theorem states that the sum of the squares of the legs in this case are going to be 1 plus 3 plus root 5 over 2 plus 1 minus 3 minus, 1 plus 3 minus root 5 over 2 squared. That's going to be the area of the square. That is equal to, we have that this is just going to be 5 plus root 5 over 2 whole squared plus 5 minus root 5 over 2 whole squared. Factoring out a root 5 from both, we see that this is going to be equal to 5, because 5 is equal to root 5 squared, times root 5 plus 1 over 2 squared plus root 5 minus 1 over 2 squared. This is just going to be equal to 5 over 4, pulling out the halves of root 5 plus 1 squared plus, let me just scroll down, root 5 minus 1 squared. Now finally we can expand these. This is equal to 5/4 of root 5 plus 1 squared is going to be 5 plus 1 plus 2 root 5. Root 5 minus 1 squared is going to be 5 plus 1 minus 2 root 5. This is just going to be 5/4 of, let's see, we have 5 plus 1 is 6, plus 2 root 5 is 6, plus 2 root 5, plus 5 plus 1 is going to be 12, plus 2 root 5 minus 2 root 5 is just going to be 12, which means that the area of the square is going to be 5/5 of 12, which is 15. Going back to the choices, we see that 15 is choice C, and we are done. Thank you so much for watching this video. Please don't forget to like, share, and subscribe, and hit the bell icon to get notified for future uploads. And as always, see you next time.